So in this tutorial, we are going to look at dynamic and static languages. So as far as programming languages are concerned, there's some kind of classification that we can do. We have the dynamic languages and the static languages. Now, as their respective names suggest, the dynamic language will kind of do something dynamic and the static language will kind of do something static. Now, these are some few examples of dynamic programming languages. Now, we have Python and JavaScript, and as for static programming, we have C++ and Java. Now, the main thing over here is, as far as dynamic programming is concerned, the data types and a lot of things are determined at runtime. So first of all, we are just going to base our understanding on the data types. The data types are determined at runtime. But as far as the static programming is concerned, we have to explicitly specify the data type and we cannot change it at runtime. So we are going to see some few examples very soon. Here, I'm going to create a new file and I'll have it dynamic.py. So inside dynamic.py, what I'm going to do is I have a name and my name is Kenneth. Now, if I am to print name over here, save this. If I'm to print name, I have Kenneth being printed over here. Now, in between where I declared my variable and before printing out name, I can do name is equal to Brony. And let me clear this up over here so that you see exactly what is being printed over here. Now, if I run this code, we are no longer seeing Kenneth over here, but then we are seeing Brony. So this is almost like copying a file onto a folder which already has the same name in there. So your computer is going to prompt you, do you want to overwrite it? And that's exactly what you've done. So the variable name has changed, the content has changed. Okay, so the content of this variable has changed from Kenneth to Brony. Now, in that same way, name could have been, let's say, 30. Okay, and this is just for demonstration purposes. Name could have been 30, and now when I run this, we can see that 30 is being printed out over here. So clearly we can see that this is an int. Okay, we need not to do a print of type, but then let's do it and see, because maybe curiosity. So we want to print the data type for name, and as you can see over here, it is an int, but then we initialize it to be a string as we have it over here. But then when it came down here, that's changed into an int, and that's essentially what the dynamic programming is all about. It is only at runtime that the data type is determined, because over here at the point of declaration we had a string, but at runtime something had happened over here. We had overwritten it and we are seeing some kind of dynamic manipulation of our data type. In the case of static programming languages, you can't do that. You can never do this. Once you have name as a string, it is going to be maintained as a string. So the next thing I'm going to talk about is, I'm going to comment all these things out over here. And this is also going to give us some kind of better understanding of how dynamic programming works. So over here, I'm going to give out some kind of thing. Now you see me do, for instance, let's say x is equal to 10, and let's say we have y is equal to 40. Now, as far as these two numbers are concerned, we can actually do x comma y is equal to 10 comma 40. Now, what we have on line 6 and 7 is the same as what we've put together on line 9. Okay, so what we have over here is this first variable is going to correspond to the first value over here, which is 10, and the second variable y is going to correspond to the second value over here, which is 40. Now, this is what we refer to as multiple assignments. So let me put out a comment over here. You can do a multiple assignment in Python, or in some cases we call it unpacking. So that's what we have over here. Now, assuming, and first of all, let's try and do some print statements over here. So let's say we want to print y. If I should run this, you are going to see that y is going to be 40. Now let me comment these ones out so that you don't kind of have any problems. All right, so if I should run this again, y is going to be 40. Now let me try and add in another value over here, which is 90. Now if I should run this, we are going to get some error over here. And let me zoom things up so that you see this very well. So this is the error value. And the error value reads too many values to unpack, expected 2. So like I said, these are the values and these are the variables. They should correspond. There should be some kind of proportionality as far as the values and the variables are concerned. We have 2 variables over here, but then we are having 3 values over here. So the value error kind of makes a lot of sense. Too many values to unpack. It is expecting 2. So maybe if we should add another z over here, which is a variable, we can have everything working out perfectly over here. Now we can print z, and if we should do so, we have z to be 90. Now let me change the value of z to be, let's say 90.5, and let me clear things up over here. Now when I print z, I'm going to get 90.5, and we clearly know that the data type in this case is now going to be a float. So the data type for z, if I should print this out, is going to be a float. Now I'm going to introduce you to a concept we refer to as casting. So let me pull this down a little bit, and let me put out a comment over here. And I have here casting. So what is casting? Casting is when we actually kind of change data types, okay? So this z we have over here originally is a float, okay? I can cast z to be an int. So what I can do is I can do z is equal to int, and if I do z over here, all that I'm trying to say is that yes, z in its natural state is a float, but then I want to change it into an int, kind of by force, okay? So let me once again clear this up and see what happens over here when I run this code. So when I run this, you can see that now z has now been chopped off, okay? We don't have 90.5, but then we simply have 90 because we want to change it into an int. So we have 90 over here, and the data type is an int as specified over here. Now we can also let's say have a variable num, okay? And it can be any variable. You can have a variable num, and we can, let's say, cast x. We can cast x, okay? As you can see, x over here by default is an int. So if I'm to cast it into a string, so what I'm going to do is I'm going to print out num, okay? Because that's what we've casted. I'm going to print out num. When I save this and run this program, we are going to see that yes, we have 10 over here. From line 16, we are printing 10, which is num. But then because we are casting it into a string, x is now a string, okay? So x will now look like this. So x will now look like this, okay, instead of what we have over here.